Alright, welcome back. So this is the second part of the provisioning techniques talk that we started for lunch. And I'll just go with a short recap so that you have an idea what we discussed before, just in case you forgot, just a few slides. So we saw, first of all, we did a deep dive after this categorization and classification approach. We did a deep dive in Chef. So we have seen Chef is a configuration management tool. You can express configuration of resources using this Ruby-based domain-specific language. You can do this in an imperative or in a declarative manner. And yeah, we have seen that Chef basically is free and open source software, but you can also go with this hosted Chef offering. Underneath, Chef is implementing the convergent provisioning automation approach. That means we implement idempotent recipes that are executed again and again until the system, for example the virtual machine, reaches the desired state. For example, if you want to install WordPress, we run the Chef recipe. If an error occurs at some point in time, we just run the recipe again and again until the desired state is reached. Then we saw Docker as a virtualization approach on the operating system level. That means we don't have a hypervisor, we do not have a separate guest operating system for each container. All the containers share the same operating system, and we have some isolation mechanisms on the level of processes, file system, and networking. Technically, there's a Docker daemon running that you can communicate using a RESTful API, and the Docker file is basically the imperative build plan that you can use to build containers in a reproducible manner. That means we basically saw that Docker implements a snapshot-based provisioning automation approach. That means we do not assume that the build Docker container instructions, so to speak, are idempotent on its own. We can assume, for example, if there is an error during the build of the container, we can reverse the last snapshot, basically the last action that was executed successfully, and then we just go in from this point and execute the other actions. So now we want to have a look, because yeah, somehow they are complementing each other, right? There are some distinctions in terms of technical details, of course, but now we want to have a look how we can actually combine these two approaches. And the first possible combination scenario would be to use chef recipes, because they are usually run directly on VMs. So usually what we do, we register the virtual machines that we provision on the Chef server, and then we can assign certain recipes to these VMs, right? This is what is usually done. However, we can also assign those recipes to containers. That means we can run the recipes in containers in a much more fine-grained level, and that means basically in a Docker file, in this build plan for containers, we can basically call, for example, the Chef client with a certain configuration and with a certain run list definition. Let's say, for example, in this container we want to call Chef to install the MySQL server. So in this sense, the build plan of the container itself is very simple. It just calls the Chef recipe that's already implemented by the community to install the MySQL server. This could be one approach. Other combinations would be, for example, to use Chef to deploy the Docker engine, because if you want to use Docker, you need the Docker engine on the machines, be it virtual machines or physical machines, right? And in order to install Docker, you could just use a simple shell script or shell command, of course, but you can also use some reusable Chef cookbooks that are implemented to configure and install Docker and maybe connect it to some management tool. Another approach could be to use the Chef server to orchestrate Docker containers. What we have seen before, we can also run these Chef recipes inside containers. So we can also use basically the Chef server as a management tooling to orchestrate all the containers that we deploy, right? And another possibility would be to integrate Docker directly with Chef to enable snapshot-based provisioning for Chef. That means basically, by this approach, it wouldn't have, so by implementing this approach, we could implement recipes that are not idempotent. Because in this sense, we could basically create a snapshot in the background after each successfully executed command or resource in Chef, and then we can basically just follow the snapshot-based provisioning automation approach that I introduced before. So this would be one possibility to integrate those two. For the next part of the talk, we are going to have a look at CloudFormation. As I've told you before, CloudFormation is an orchestration tooling provided by Amazon, and because it's provided by Amazon, it's mainly targeted to orchestrating resources and in the Amazon cloud. I mean, if you know, in the Amazon cloud we have a huge variety of services, like EC2 for virtual machines, some storage related services, for example DynamoDB, database as a service, and so on. And you can now use this language basically to create so-called templates. These are basically models, very similar to HOT, what we've seen in Tosca. And it's basically a declarative infrastructure topology what you create. Technically, it's a JSON-based domain-specific language, so it's also a bit old-fashioned because it uses brackets, as we have learned in the morning, right? And you can instantiate those templates, and these instances are called stacks. The CloudFormation API can be used to manage those stacks. For example, you can create new stacks if you have a CloudFormation template that describes your whole application topology, for example, a WordPress application including the database. Then you can just use the CloudFormation API to say, okay, I want to have a new stack of this application for my testing environment, for example. So it's very easy to use. And as I said before, it's mainly targeted to orchestration of Amazon Cloud resources. For example, VMs hosted on EC2, auto-scaling mechanisms, CloudFront, which is basically a content delivery network, and there are a bunch of other services that you can tightly integrate and orchestrate using CloudFormation. This is the structure of the CloudFormation template. So you typically have a textual description that just says what the template is and what it does. And then you have a set of parameters. These are basically the input data. So you define which kind of data you expect the user if a new stack of this template is created. For example, you have some variability points in terms of the size of the VMs that are provisioned, or maybe you want to run this CloudFormation template in a certain region, you want to run it in Europe or in the US or whatever. These kind of variabilities you can capture in the parameters section. Then you define all the resources. These are the resources that are hosted on the Amazon cloud, like a database instance, like virtual machine, and so on. And you have some output values, because when you provision such a stack, in the end you want to have some results, for example the endpoint where you can reach the application. So you need some kind of HTTP URL to get the endpoint, how to call the WordPress instance that you just created on Amazon. And then last but not least, the template format version, because there's also an evolution of the template format itself. This is a simple Hello World template, just to give you an impression how this could look like. So you have a description, then you have the parameters section. This is not well formatted. So this is a separate section. You have, for example, a key pair definition here that basically says you expect a certain key pair identifier, because you need this in order to access your machine after the provisioning using SSH credentials. So you have some SSH key uploaded already to your Amazon account, and now you can exactly define which kind of key pair you want to use for these machines, right? And in the resources section, we have only a single resource here. This is an EC2 instance. You define the type. It's basically an instance of the EC2, and then you basically refer to the parameter section by using this reference function here. You say, okay, the key name is basically the value that is given here by the user when a new stack is created. And in terms of images, because you have to use a certain image, for example, an Ubuntu machine, Red Hat machine, or whatever, you can just drop in the image ID here. And then the output values that you basically want to give back the instance ID of the EC2 instance that is created here. When we go back to the WordPress application stack that we have seen in the beginning, we will have a look now how this could be implemented using CloudFormation. So description is clear. Then you have a bunch of parameters. For example, you define that you need to give a root password for your database. And here you see already some constraints you can introduce. You see, for example, the password has a minimum length of 1 character, maximum length of 41 characters. You have a certain pattern that you allow for the passwords because there might be problems with some special characters, right? And also for the instance type, you can also say there's some default value, and in this case, it's not an arbitrary string that is accepted. You just have a number of options here, basically the different machine sizes that are actually provided by Amazon. So you cannot put an arbitrary string into this field later on. Then we have some mappings. We will see later on how this helps us to abstract, for example, from certain regions in Amazon and also from certain machine instance IDs. We can use these mappings later on to say, for example, okay, if we want to have a M1 small machine, which is 64, which has a 64-bit architecture, we can basically map it to this kind of image ID if we run it in the regional US list. So here in this case, the resources section looks a bit more complex. So again, we have an EC2 instance definition. Then we use this CloudFormation init functions to say, okay, we need to install certain packages on this machine. We say, for example, in this case, we need HTTP and PHP. HTTP is basically the Apache web server that we use for our application. And then, of course, we need also the PHP environment. We might need additional packages like the MySQL server if it's installed on the same machine. Then you can also define files that have to be created on the machine. For example, you can say a file needs to be created in this directory, which is called setup.mysql, and then you basically give the strings, basically that they are joined together, so each line gets joined together and is written into this file. And as you see here, you have some references to the parameters that were defined before. So this is not just a hard-coded string, this will be resolved by the CloudFormation engine once you upload and once you create a new stack of the CloudFormation template. And then, depending on what the user inputs, for example, for the database name, username, and also for the password field, these values will be directly dropped here and written to the file or to the disk. And later on, this file can be used, for example, executed against the MySQL server to create a new database, to create some tables inside the database and so on. And here you have for example, the configuration file for the WordPress application. Similarly, you basically say, okay, the content of this file looks like this, and also you have these references. For example, we refer to the database name, the database username, and the password that were also given in the parameters section as input values for this concrete instance of our application stack. Then, very similar to hot, we also have these intrinsic functions. For example, a function that is called findInMap. We defined these maps before to find out, for example, which is the correct image ID to run a certain instance in a certain region. For example, we want to run this application stack in the US East data center of Amazon, and the same Ubuntu version of the image may have a completely different identifier in another region. So we need this mapping in advance to exactly define which kind of image we want to use in the CloudFormation stack. And the same is here. Here, for example, we create a shell script that basically executes the MySQL commands to create the root user, to set the root password, for example, and so on. So we can basically inject arbitrary system commands on this level to configure our resources. In this case, we are dealing with virtual machines according to our application stack. Then, of course, we also need to deal with web server security groups, because we need to ensure that, for example, port 80 is reachable from the outside world, because in the end, after the whole application stack is deployed, we want to ensure that we can reach actually the WordPress application. And yeah, in this example, we just expose 2 ports, which is one is the 80 port, the HTTP default port, and the 2020 for SSH access. As an output, we just get the endpoint URL, so we get the attribute from the web server definition, we get the attribute public DNS name in order to retrieve the endpoint URL that we need to access the WordPress application we just deployed. So once we have defined such a CloudFormation template, we can now upload it to Amazon, and then if we decide to create a new stack based on the template, we end up with this kind of UI. So for example, if we define, for instance, 2 parameters in the parameter section, db root password and instance type, we see here 2 corresponding fields that we can actually use to put in our concrete values for this instance we are creating. So this is the link between the parameter section we have in the template and the UI that we see later on when we create a stack. In terms of community, we have seen, for example, the Chef community is quite active, the Docker community is also quite active. You also find quite a number of CloudFormation templates that you can use as a starting point to model your application using CloudFormation. And currently there are around 130 sample templates provided by Amazon with different application stacks, different middlewares, different topologies. Some are single node deployments, some are using RDS, for example, database as a service instances, so you don't have to deal with the database scaling and so on. And there are also some prominent customers that are using CloudFormation today, like Adobe or Expedia, for example. So this was CloudFormation, basically, and now I will show you one slide regarding the orchestration. So how can CloudFormation be used to orchestrate, for example, Chef and Docker artifacts? It's quite easy, because you have in the resources section, you can define arbitrary commands. That means basically, you define, for example, 2 virtual machines. You have 2 EC2 machines, and on one machine you want to install the WordPress application itself. So you just use the community-provided WordPress cookbook, and you just call the Chef client on this certain machine to execute this script, basically. And the same you can do, for example, with Docker or any other kind of configuration management technology. You just install the client and basically run the artifact that is provided by the community. And so you can use basically CloudFormation as an orchestration means. But so in the first look, this looks everything fine, but yeah, there are some problems with this approach, because CloudFormation, first of all, is very infrastructure-centric. That means you focus heavily on how to orchestrate virtual machines, database instances, and stuff like that. You usually don't have your application topology in mind, because you have to think more in the direction of what resources do I need underneath and how do I have to distribute the different scripts. So it's heavily infrastructure-centric, but what we actually want is more application-centric thinking. Like, for example, the platform as a service frameworks. Furthermore, it is bound to Amazon Web Services. That means to the public cloud, first of all, and even worse, it's bound to a single provider. But how to do, for example, orchestration in other clouds, for example, in hybrid clouds, private clouds, first of all. And here, of course, you can use OpenStack Heat, which is very similar to CloudFormation. But still, what about hybrid cloud management? I mean, when you have distributed, let's say your application is distributed across an OpenStack cloud that you have running on-premise, and some parts are outsourced to Amazon, basically. So how do you deal with this? This is also a challenge. And CloudFormation is a strongly declarative model, because you only define the resources and how they are interrelated. This is fine for provisioning, as we heard before. But what about if you have some very custom, very specific management actions that you have to implement that are not only executables on some virtual machines, right? You have to, for example, licensing management, or you have to add a user, and that's not just a single SQL command. Several components of your system may be involved here. So how you can do this is also an open question. And with this, this is basically the end of my talk. Do you have any questions?